Beyond instantaneous velocity, what are some of the other applications we can have? Well, one of the huge things in the business world and economics is rates of change. Rates of change in economics are called marginals. So this says another important use of rates of change in the field of economics. Economists refer to marginal profit, marginal revenue, and marginal cost as the rates of change of profit, revenue, and cost with respect to X, the number of units produced or sold. An equation that relates these three quantities is P equals R minus C. So let's think about what this stands for. So revenue is the money that you bring in. That's not necessarily the money you make, though, because you also have expenses or costs. So costs is what it costs you for making the product, running your business. Revenue is the money you bring in. So how do you find what your profit is? You take the money that you brought in minus your expenses. So what they're using here is the notation for derivatives. The derivative of the profit with respect to X is called the marginal profit. The derivative of revenue is the marginal revenue, and the derivative of cost is called the marginal cost. So if you hear marginals, they're just talking about the derivatives, which is just the rate of change. So let's look at example 5 here, finding the marginal profit. It says the profit in dollars derived from selling X units of an alarm clock is given by P of X equals 0.0002 X cubed plus 10X. Part A says find the marginal profit for the production of 100 units. Notice it doesn't say the profit of 100 units. If it was the profit of 100 units, we would just directly plug it in. So again, when we're finding a marginal, we're finding a derivative. When we're finding a derivative, we're finding a rate of change. And remember, this would be dP dx, the change in profit over the change in X. Profit in this terms is measured in dollars, as it says, the profit in dollars. X here is the number of units. So whatever we get as our answer is going to be dollars per unit. We always need to label our answers on any of the applied problems. Okay, so let's see what this is. What we need to do is first find the marginal profit, P prime of X. To find that, we find the derivative of the profit function. Well, the profit function is 0.0002 X cubed plus 10X. The derivative of that would be 0.0002, the coefficient, times the derivative of X cubed, which is 3X squared using the power rule, plus 10, the coefficient, times the derivative of X, which is just 1. So this would be 0.0006 X squared plus 10. That's our marginal profit, but what it asked for is at X equals 100 for the production of 100 units. So the marginal profit at 100 units would be 0.0006 times 100 squared plus 10. Plug that into your calculator and let's see what it is. I'm getting a value of 16. So the marginal profit is $16 per unit. I want to be very, very clear. That is not your actual profit. We are not saying you are profiting $16 if you sell 100 units. What we are saying is the increase in sales from 100, and since it's per unit, it'd be from 100 to the 101st unit. The change in your profit should be $16. In other words, you should make, let me write this down, you should make $16 profit, because it's positive, it is a profit, not a loss, for the sale of the 101st unit. Actually, the 100th unit. Between the 100th and 101st unit, you should make $100. No, that is the 101st unit. The 101st unit. Okay? That's what that's saying. That's not your total profit. That's just the profit for that one item. Let's look at this. It says compare the marginal profit with the actual profit obtained by increasing the production level from 100 to 101 units. So our marginal profit is the estimate of how much you make. Let's find out how much you actually did make. So how do you find out how much you actually did make? You're going to do the profit of 101 units minus the total profit from 100 units. This is going to give us our actual change in profit, the actual amount that we made. So the marginal, the derivative, is the estimation of what we should make. The actual would be the actual change in Y. That's what we actually did make. So I'm plugging in numbers here, multiple numbers into the same formula. I'm going to use my table here. I'm plugging in for x, and I'm plugging it into the profit function, which is the original function, 0.0002 x cubed plus 10x. The numbers that I want to plug in are 101 and 100. Use that table feature on your calculator. I'm hitting table. I'm clearing out the function. I'm putting in 0.0002 x cubed. Hit the right arrow to get out of that cubed. I hit plus 10x. I hit enter. Doesn't matter what start is, doesn't matter what step is, just make sure you have ask x highlighted. Hit enter on OK. Type in 101. Let's see what we get. I'm getting 1216.06 if I round to the nearest penny. Let's type in 100. Type in 100, hit enter, and I'm getting 1200 exactly. And so what do I want to do? I want to do the profit from 101 units, which is 1216 and 6 cents. Minus the profit of 100 units, which was 1,200, I'm getting a total of approximately $16. That's how much the actual change was. So look at our marginal change, which was $16, and look at our actual change. Sorry, that should be $16.06. The realistic change was $16.06. So what you'll find is that's really, really accurate. If we do small distances of change, the sale of 1 unit, the derivative can be an excellent estimation of what's going to happen in the future. So if it's a small distance, it's accurate. But if we did this for a large distance, for instance, if we said not for 100 to 101 units, but what about from 100 to 1,000 units? The larger the change that you are estimating for, the worse the estimate is. So what we want is estimates. When we're using marginals, we're using estimates really close. If we're estimating sales for a company, we might estimate sales for the next year or the next month or the next week, but we're certainly not going to estimate sales for the next decade or the next 100 years or anything like that.